Hey guys, welcome back. Today we're going to talk about the Dayton RS125-8, and I'm going to be actually working with 123toid in his YouTube channel. You should go check it out. I'll put a link in the description, but we've put together this speaker idea using the Dayton RS125-8 and the new Dayton RST28F tweeter. So today we're going to test this woofer, see what it can do, and then the next video will be a test of this tweeter to see what it can do, and then we're going to look into putting a crossover together for this speaker and see what the speaker can do and collaborate a little bit. So pay attention to both of our channels on updates and stuff like that. 123toid is going to focus more on the box and some of the crossover design. I'm going to focus on testing the drivers and work on the crossover design as well, and then we're each going to do a build video of kind of a finished product. So anyways, let's get into it. Let's see what this little woofer can do. It sure is little, it sure is cute, but it packs a big punch.
Okay, this is the packaging that the Dayton comes in. It's a nice compact little box. I find driver packaging is usually pretty bad, so even though this I don't find very good, this is about middle of the pack. This is kind of what a lot of driver manufacturers will give you, a box with a little wedge of styrofoam or something like that. Overall, we got a cast frame basket, a nice aluminum cone with a pretty little phase plug in there, nice beefy terminals. I really like the build quality of all these RS drivers, and this one is no exception. They look great, they feel solid. Not much to complain about here, especially for the cost. Normally you don't see this kind of rugged looks on a driver of this price range. Here I label them sample 1 and sample 2. This is so I don't get mixed up. So if any of my results I need to go back and double check them or anything, I am able to do that. And I leave these stickies on for as long as I take with this speaker. These are very compact speakers. They're about 165 millimeters wide and 285 millimeters tall. So pretty small baffle. And especially when we talk about the tweeter, we'll see why it's a little small for that tweeter. There's some diffraction, and but it's overall it's really good dimensions for this woofer. Here I am. I'm going to do some impedance testing. And just quickly get the free air measurements of these. These have been broken in, and overall we get some excellent agreement. A little bit of difference around the FS, but overall these are bang on. You can't ask for much better than this, really. Okay, here we just have zoomed way in on the impedance graph so we can just get a look at how close of match this really is. You can see there's a minimum in the valley there of the impedance plot. We have 6.5 ohms. This is a nominal 8 ohm driver. Okay, now I want to get the TS parameters, so I put it into the box, take a sweep. The software uses the difference between the free air measurement and the measurement in the enclosure when I tell the software that it's 3.3 liter box. It can do back calculation to figure out what those TS parameters are. This box could have been a little smaller for that exercise, but I didn't want to have to build 2 boxes, so I'm using the test box, and this is the difference we see here. These are the TS parameters that the software came up with. This is sample 1, and you can see it matches very closely to sample 2, and overall we get pretty good results to work with for box design. Okay, now I'm just going to install these drivers into the box a little more permanently. Still just for testing purposes, but this way we can drag them outside and do our work here. These test boxes were not meant to look pretty. They're just meant to work while I work out the crossover with 123toid. And so if you're wondering why I'm working on such an ugly looking speaker, that's why. They will go in the garbage eventually. I measure outside because you want as few of reflections as possible, and certainly, actually it's not about the number of reflections, it's about how far away the reflections are. So this helps me get as far away from the ground as possible so that I can get very clean measurements all the way down to below 100 hertz. So now that I'm all set up, I can get this result. This is sample 1. We can see where the baffle step is happening, and I'm actually using this box and driver to set up another video to talk more about baffle steps, so stick around for that. But overall, we can see that the ultimate sensitivity of this driver is about 86 dB, and at 8 ohms and this size, that's actually pretty darn good. The trade-off is you can see the sealed box roll-off is happening around 150 hertz. Some of that is baffle step loss still happening, but overall this thing needs to be in a ported enclosure, and you can't expect it to reach way down. Okay, now that I got that measurement, I can swap over to sample 2. I always check the mic spacing because things can move, especially up on a ladder like that. Okay, here's sample 2 in green overlaid with sample 1 in red, and we can see really good agreement above about 500 hertz. This area is especially prone to discrepancies in most drivers as you get closer to the woofer breakup and the baffle diffraction and stuff like that, but we see pretty good agreement between the two. Where we do see an issue is below 500 hertz. For some reason, sample 1 is a little more sensitive in the bass, for whatever reason, and I was a little unsure if maybe had a bit of an issue, so I checked this indoors as well when I did my off-axis measurements, and it's a real thing. Sample 1 and 2 show a little bit of discrepancy here. I'm gonna work with sample 1 going forward. Okay, I use sample 1 to take off-axis measurements in the shop. It's a very tedious process. I normally spin the speaker stand rather than the whole thing, like my weird enclosure. I usually just spin the top portion of it, but I tried doing it this way. I don't think I'll do that again. It was really tedious and a pain in the butt. But anyways, it got the job done. So here we are. We can see 15-degree increments out to 60 hertz. Overall, I'm quite pleased with this. We have nice, smooth off-axis. What you're kind of looking for is even spacing as you move off axis, and we have that all the way out to like 4,000 hertz or even 5,000 hertz. Right around 6,000 or 7,000 hertz, things start to get a little squirrely, and we can see indicators of breakup and energy storage and things like that happening in the off-axis response. Overall, that is super high in frequency, especially for the tweeter I'm going to be pairing with this, the Dayton RST28, which can cross down much lower than that. So this driver is very happy, despite its aluminum cone, to cross over very high. And we'll talk about that when we look at distortion. In distortion, I set the level for 92 dB, which you see here. I might have gone a little hot, but I have to think about diffraction stuff. And then the baffle step area is definitely below 92 dB, but that's just kind of the benchmark I use. I don't talk about distortion much on this channel, but I am going to talk about it a little more for these drivers just because I'm actually going to do a crossover design for them. This measurement is taken at a meter, and then I move the mic to 10 centimeters away and then take the measurement, and then that's how I get this measurement, which is cumulative spectral decay. So looking at the CSD, you can see the breakup is happening around 10,000 hertz, super high in frequency, and below that things are generally pretty clean, especially for a woofer. Overall, things look pretty darn good here, I think. Okay, then I take the harmonic distortion test, and we're going to talk about the bass results and the mid-range results for this speaker. So here's just an overall look at what you got, and you can see overall from between 200 and 2000 hertz, things are pretty clean on this driver. Not much to complain about here. You can see some increases as you go below 200 hertz and above 2000 hertz. Overall, for the bandwidth we're going to be trying to get out of this driver, things are pretty clean, so I'm happy to see that. But let's take a little closer look at some of the individual results, starting with 1000 hertz. So at 1000 hertz, second order distortion is well over 40 dB down. This is before or right around where our filter is going to take over. 2000 hertz, we're 45 dB down. We got tons of healthy space there for crossing over. Going from 200 down to 100, you can see we're still very clean, 35 dB or so. Now at 80 hertz, things are starting to get closer to where we like to see them. So this should be where we cross over to subwoofers. We're only 30 dB down to our second order distortion. 60 hertz now, things are starting to get a little dicey. We're only like 20 dB down from third order harmonics, and 40 hertz, things are very ugly. This driver should not be used below 60 hertz. I could hear this when I took the measurement. This will sound disgusting. This thing needs to be crossed over 80 hertz and above or thereabouts. Okay, and like all my tests, I chuck them into XSIM, the FRD and ZMA files, chuck them into XSIM and start fooling around just to see what the driver can do. This is kind of the fun part, so I can't help myself. I always start with a second order filter and see what I can get out of that real quick. Overall, this thing has a nice smooth response, so it shapes up pretty quickly. There is a bit of shelf in the response, right around 3,500 hertz, that may need a little bit of tweaking and adjustment to get it to roll off smoothly. And because this is an aluminum cone, a lot of people like to use a notch of some kind on the woofer breakup just to shut it up a little bit and keep distortion out of the sound. I don't think that's going to be required for this driver because it's so high in frequency that the crossover filter is going to slam it down into nothingness without much problem. But for the sake of interest, I just quickly put a little notch on here to see what it could do. And like I say, doesn't seem necessary, but you can filter it out pretty easily. Overall, this thing works really easily, and I'm excited to use it.
Alright guys, there it is. I hope you enjoyed that. The Dayton RS125-8 sure is an interesting little driver. Quite a performer, like all the RS drivers I've used by Dayton. They do quite well, honestly, especially for the price. So follow along. We're going to test the tweeter next, which is the real treat, I think. A lot of people are interested in what it can do, and continue to follow along for the rest of the whole speaker design. Just a reminder that you can download the files from my Dropbox link. I'll include that in the description below. You can tinker in your own software choice or XSIM or whatever for what this woofer can do. And if you'd like, follow me on Instagram, impulse_audio, I believe. Can't remember if there's an underscore in there, to be honest. So anyways, guys, thanks for joining me. Subscribe, like, all that stuff. Check out some of my other videos, and definitely stick around for this tweeter video. Thanks guys, bye.